Good morning, ma'am.
Good morning.
Is it visible now?
Yes, ma'am.
Yeah. Today my topic is taxonomy of bugs. Taxonomy of bugs in the sense, uh, while testing while testing a software, what bugs will occur, like types of bugs. The major categories of bugs are these: requirements, features and functionality bugs, structural bugs, data bugs, coding and documentation bugs, interface, integration and system bugs, and testing and test design bugs. Yeah, let us see one by one. Requirement bugs. Requirement bugs. These bugs rise due to the specifications which were taken by the system, uh, like type of application, the operating system which we are building software. Next one, feature bugs. Feature bugs are mainly caused due to the problem in specification. Like there are two possible cause of bugs: missing feature and wrong feature. And the next one is functionality bugs. Functionality bugs means the bug caused due to the functionality of a specific part of the software. Or for detecting functionality bugs, the specification features that are accurate, transparent, achievable, and testing are not sufficient. The high-level specification language include short-term support and long-term support. And the next one is structural bugs. These bugs are caused due to the error in the structure of the program or code, such as syntax error or logical error, any control errors. Based on the kind of error, these structural bugs are divided into like control and sequence bugs, logical bugs, processing bugs, initialization bugs, data flow and anomalies. The next one is coding and documentation bugs. The bugs which are caused due to the errors in the coding or source code are known as coding bugs. These are some errors such as syntax errors. These errors does not affect, they are not important. Documentation bugs are caused due to small mistakes or wrong and incorrect statements in the documentation. As they are simple and they are not harmful to the software. The integration bugs are as follows. Like in integration bugs due to the interface between two or more modules. Like there are two types of interfaces: external interfaces and internal interfaces. External interfaces in the sense communication possible with the outside world. Internal interface in the sense it includes inaccurate protection against the corrupted data. And operating system also interface between the user and the system. And the next, integration bugs are occur when the interfaces are integrated in between the assumed testing components. A smaller components make use of many interfaces, because of which there are more chances of integration bugs to occur. These bugs arise from the difficulties or inconsistencies between the components. Next one, system bugs. System bugs are revealed when the system testing is performing. System bugs occur when there is a complete interaction between different components such as program, hardware, data and operating system. When system bugs occur during the system testing, it is very expensive to fix the bug because of its complexity. Next, testing bugs. These bugs occur when we test the software, like though the specifications are correctly defined and implemented, which the software is examined and assessed is incorrect. Different solutions for these testing bugs are test debugging, test execution automation, test quality assurance, test design automation. Thank you, ma'am.
What about others? A2. A2. 509. 506. Okay, start the presentation.
No, actually, I didn't hear that day, ma'am, about the presentation.
Yeah?
Actually, I didn't hear about the presentation, ma'am, that day.
Why? Hello. What's the
Hello.
reason? What's the reason? Why?
That day I couldn't listen about the presentation, ma'am. Can I know again?
Purpose of testing. We have to ask me, right? From what? From the topic name. What about 506 17 series? 506. Start the presentation.
Ma'am, I haven't prepared, ma'am.
Why?
I haven't known about the presentation, ma'am.
So you have to ask me, right? If you don't know the topic names.
Yes, ma'am.
Now, if you are saying you to present that, you are saying that you don't know the topic name. What's the reason? What is the thing you know? What you have to ask on that time, right? While I am
Yes.
giving you to the topic names.
Yes, ma'am.
So now, okay, your topic name is purpose of testing. Your number is sorry, 506 means dichotomies. Okay, now. So we will start our class. So last class I have discussed about the visible to you guys. So in previous class we have discussed about the path, okay? The path testing control for graphs. So for the clarity purpose I am doing with this PPT. Okay. So in the path testing we have last class we have seen the flow graph, all those things, right? So flowchart is nothing but this one, and flow graph is nothing but this one. So this is the difference between a flow graph and the flow chart. Okay. So I said you in the last chapter there is a difference between, there is a similarity but the representation is a different. Okay. So this is the difference between the flow chart and the flow graph. You can look at these images. So this is the flow graph notation. So this is two symbols notations we are using in the flow graph. That is circle and the edge. So this is the circle. It will show the nodes. Okay, statement. It will show the sequence of flow graph. This is the. It will show the links between the graph. Okay, between the nodes. Okay, so previous class I have given the example of saying this program. So this is the flow graph example. Okay, this is the flow graph diagram. Okay, this is the program. So each and every we having the link with the so here input xy nothing but second line is nothing but a2. Okay, so linearly we are giving the, if you are having decision, so we have given the decision table decision over here. Okay, so next we have the So decision is nothing about quantity, one is control and behavior. So last class I have said about the three things: decision, tension, and the control. So this is the thing: switch cases, while loop, and unit loop. So that time we are using this decision, okay, in the flow graph. So look at here in this example we have the decision over if statement x is equals to x is greater than y. Then this is the fifth line, okay. So here we are using the decision table, okay, decision flow graph. So this in this stage type of stages we are using this decision, okay, this decision. That time we are drawing the flow graph like this, okay. We are representing that decision as this one. Decision is nothing but yes or no. So in that, if you are getting the yes or no, that time you are using this type of graph, okay, implementing this type of graph. Well, when switch cases, while loop, unit loops, if you conditions loops are going occurs, that time we are using this decision, okay. Next we have junction. Junction is nothing but this one, okay. Condition, go to condition. So in the loop, go to loops. So that time we are using this junction, okay. In this statement we have the junction over here, it and if. So here is the junction loop, okay. So that time we are providing the junction loop over here, junction in the flow graph. Okay, next we have the process block. Process block is nothing but one after the other sequence of straight line. It's showing the each and every line in the sequence loop, okay. And this is the another example of flow graph. So same, this is 11 lines we have represent in this, and we have the loop over here. So we are using loop, okay, and the junction over here. This is a junction, okay. So we are calling in the flow graph like this. We have to represent our code in this flow graph. So we are finding the path in this flow graph. So next we have the what is path. Path is nothing but the sequence of statement that start at the end of entry of a junction and decision and everything. So path is nothing but a from starting we are taking the one path, okay, 2 3 4 5 6 7 and 8. So we are starting the program from here. Second line is running, third and fourth, fifth. Then it are having the s, if s, so it will go 6th, 8th, 9th, and so last class I have explained about this. Same like that. This is the path, okay. This is each and every flow graph. They have so many paths, okay. Depend of the statement we will find that the path over there, okay. This is the first path of that example, okay. Next is we have the second part, 2 3 5 4 7 8 9. So if it is no, then it will go over here, okay. This is another part of our example. Next we have the path testing strategy. Is nothing but statement testing, branch testing, and the path testing. In the statement testing is completely based on the nodes 1 2 3 4 5 6. This is based on the nodes, okay. This is the loop true and false. So here we will 1 2 3 4 5 6 7. This is the statement testing. So this is the statement testing will be there in the path testing. So second we have the branch testing. In branch testing is nothing but we are going with the links, okay. A from here we are giving A B, okay. So only link 1 to 2. This is the link between them. So this, and from 2 to 3, 3 to 5, 5 to 6, 7 to 8, 9 to 10. This branch we are going over here, okay. So we are giving A B C D E F G H I J. So we are providing the branch over there. So next we have the path testing. Path testing is nothing but just I have shown you that. So flow of thing, okay, branches 1 2 3 4 5 6 7 8. And this is the path testing. And next is the 1 2 4 5 6 7 8. And this is another path testing, okay. Statement testing. So this is the next path of our example graph. And next we have one more path, 1 2 3 4 5 6 7 8. So we have two loops over here, so we can go from here 4 5 6 7 8 9 also. So this is the one more of path testing. So on here we are now what we'll do. Just now we have seen the four path. Okay, so that is 1 2 3 4 5 6 7 8 9 1 2 3 1 2 4 5 6 5 7 8 9 then 1 2 4 5 6 7 8 9 1 2 3 5 6 8 9. This is the four path test we have find it over here. Okay, in this diagram. So now we will do the test coverage table. Okay, so first is 1 2 3, okay, 5 6 7, sorry, 5 6 8 9. This is the one path, that is A B D F H J. Okay, this is one path. Okay, next we have next path is 1 2 4 5 7 8 9. This is the another path, that is A C E G I J. This is the another path. Okay, and then next is our 1 2 3 5, okay, 7 8 9. That is A B D G I J. This is the one more path. And the next we have the one more path, 1 2 4 5 6 8 9. That is A C E F H J. This is the another path. Okay, so in the path, second path, we have the true. Okay, this is over here true, and the going from here fifth, so we have the true. So we are taking decision in the second stage, in the second line, in the second node. We have the next is true. Okay, and the same like in the fifth state we have the true over here. Okay, we are writing over here true, and we are passing from there. So we are passing in the first to second node. We have the A. Okay, process line. So we are clicking over here. So we are giving a mark from 1 to first node to second node. We have the link, process link is A. So we are marking as A. Next we have the in the link 2 to 3 we have the link is B. So we are marking over here as a B. Next 3 to 5 we have one link, it is called the D. That is we are marking over as here D. Next we have the 5 to 6. So that link we are marking as over in the process link. Okay, 5. Next is we have the 6 to 8, that is H. H we are marking over here like H. Okay. Next we have 8 to 9. 8 to 9 process link, it is J. So we are marking as a J as a link. Okay. So next we will see the same like that. We have to find out the first second. The second path is 1 2 4 5 7 8 9. So we have A C E G I J. So this is the process link. Okay, so we will check that in the second stage we have the F, false statement. Okay, so we are using over here false. Okay, and in the same thing in the fifth line we have the fifth node we have the false. Okay, so we are writing in the decision, we are taking the false over here. So we are writing in the decision at the link or at the in the node of second and fifth we are taking the decision. So that's why we are taking this decision and we are writing the nodes names and what decision we are taking on that path we are writing over here. So in the first part we have taken the decision, in the second and fourth we have taken the true. In the second path we have taken the decision false. So you are writing the false, and the what the process links are providing by in the middle of each nodes we are marking as a marking with the nodes. Okay, so in the first and second nodes we have the A. Okay, so we are marking as a marking to the A. Okay, next we have the C, so we are marking over the C. Okay, next E, so next G. So look at here, you have G and the A, I, so I and J. So we are marking over there. So next we have the path is 1 2, okay, 3 5, next 7 8 9. So it may be also happen 1 2 3 5 6 7 8 9. So this will be one more path of our example graph. So here look at this. So we have the process link is A B D G I J. This is our process link. So in the second decision or in the second node we are taking the true decision, and the fifth nodes we are taking the false decision. Okay, so we are writing over here true and false. This path is going like this, right? So in this we have, in the fifth decision we are taking the false, and in the second node you are taking the true. So you are writing over here in the node, second node you are taking the decision as true, and the fifth node you are taking the decision as a false. So you are writing over here. Next we have to flow of graph. We have to check the flow. Okay, next we, first to second we have the A. Okay, A, and next is B, next D, G, I, J. So we are marking over here. Okay, next we have the processes 1, 2, 4, 5, 6, 8. So this is the graph of 1, 2, 4, 5, 6, 8, 9. So in the second statement you are taking the decision as F, and in the fifth statement we are taking the decision as a true. So we are writing the same like we are doing the past statement, and we are marking over there. So it is a coverage area of path testing. Okay. So you have, when you are doing the path testing, you have to write the coverage area. In this coverage area, you have to write a paths over there and the decision where you have taken the decision. It may be it's depend upon your program how many decisions we are taking in the program. So next we have the process lines. What process line we are taking? So what we are defining is nothing but we are defining these three things in the path testing. Okay. So the statement testing, branch testing, and the path testing. First we are defining the statement testing, then branch testing, then the path testing. Okay. So this is the another example of our path testing. Okay, this is our code. Okay, this code is completely as a flow graph. Okay, completely implement as a flow graph. This is the our code, and it is will be written as a flow graph. So look at here in the fourth line. This is your fourth line of your program. So this is your node, and it is going to the second node pattern. So when we are having the decision 9th statement, so you are taking the decision table over here. Okay, in the flow we are doing over here. Okay, next is this 13th statement. So whenever you required you are taking the decision. So you are implementing your program as a flow graph. Okay. So basic path testing. So in this basic path manner, we have to select the shortest path. Okay. So in this we have the first path is 4. This is the diagram of this example. Okay. Second example, this program diagram. So in this, look at here, 4, 5, 6, 7, and we are going like this. This path we have selected. This is our path. Okay. This is the example, and so in this. How many paths we can find out? Can anyone say me that? Can anyone define any path? $23. Okay, 522. 558. 558, 18 series.
Yes, ma'am.
Okay. Say me the path of this diagram.
Like
Another path.
another path. Okay. One, ma'am. Can you zoom a little bit, ma'am? I cannot see the numbers of the nodes. Okay, ma'am. 4, 5, 6, 7, 8, 9, 11, 12, 14, 15, 20, 22,
Wait. From 12 directly, how you are going to the 14?
12 to 13, ma'am. 12 to 13, 14, 15, 20, 22, and 23.
Okay, one more path.
Uh,
How many paths you can define in this diagram?
let me go, ma'am. 2, 3, 5, I guess, ma'am. 2.
So we have 4 paths over there. Okay, in this 4 path we have taken the decision on the 9th statement, 9th line, and the 13th. Okay, look at here 13th, and over here 14th, and the 16th. Okay, we have taken decision over here. So in this year, look at here, 9th, 14th, 16th, 30th. Okay, so in this this is your path. You have selected the fourth path, and you are taking the decision over here in this fourth path. Okay, this is your test cases A, B, C, D. So this is your test cases and the expectation result, not a triangle. So this will be find. We will look at next class how you are taking that. Okay. So next. So are you clear with this path cases? Wait. So next we have the topic of one second, guys. So are you clear with this topic, guys? Are you clear with this basic thing? Hello. But path cases, how to take the path testing?
Yes, ma'am.
How to implement flow graph? You know that? Are you clear with this flow graph? So now we will go the next topic, that is notation evaluation. In this notation evaluation, what you are doing means the graph, control graph, flow graph. Okay, we are representing the control flow graphs of a program structure. Okay, the notation change the mode in the certain of control flow graph. The process blocks were not really neat. There is our implementing process every line joining just joining junctions are in decisions. So whenever you're taking the decisions things and joining the junctions, so that we are representing in the flow graph. Okay, control flow graph. We cannot need to know the specific of the decision, just the fact that there is a branch. Okay, so here we have some kind of examples. Okay, with that you will get the clarity what is actually notation evaluation. Okay, so just in this notation evaluation, what you are doing is you are replacing them into the simple numbers. Okay, just we are what we are specifying target labels names are not important. Okay, just the fact that they are exist. Okay, so if you are giving any particular name for the table, there is, if you are giving a label name are not important. Okay, just the fact there is they are exit, that is enough. Okay, so we can replace them by the simple number. So with that thing we are converting into the simple number. Okay, so to understand this we will go the example. Okay, so programming language, this is called the programming design languages, PDL. So this is the PDL. Okay, in this, what is this is the, we are in with this code we are implementing a classical, okay, classic flow graph. Okay, so look at this. For control flow graph, we are implementing the control program or classical program flow graph. So in this, what you are doing is, look at this example. First example, this is a programming design languages. Okay, so that program. So with that, we are implementing the flow chart and the flow chart. Okay, look at this one. In the so look at my cursor. This is your code. Okay. So with this code, we are dividing into the flow graph. We are that diagram we are implementing the flow chart or flow graph. Okay. First, we are implementing into the flow chart. So look at this flow chart. Flow chart is not. We will call it the one-to-one flow chart. Okay. This is a one-to-one flow chart. What we are doing is, first we are transacting the program into the flow chart. Okay, where we have to type one from one classes flow chart. Okay, note that complexity has increases and the clarity has decreases. The complexity increases and clarity decreases, and then we had to add the labels. Okay, like loop x and the y loops we are adding over there. Okay, so look at here. Just look at this program, and what you are doing is, so this is your first line we are representing over here. Okay, in this node, next we are linking the second node and the third node, and this is your decision, and we are adding the JO over here. Okay, next we are going to the next statement. Okay, next we are going to the SAM. Next we are adding over here. So this is you are adding a John and SMS. Just we are giving the labels. Okay, we are just representing with that something we can do. We can write the over there x and x, y, anything you can write over there. Okay, we can just we are representing over there. So look at here. So this diagram we are representing the one-to-one flow chart. This flow chart is called the one-to-one flow chart. Okay, this is the flow chart. Okay, so this program we are representing the link nodes, and this line is we are representing the writing in the one node, and we are giving to the link over there where we are required the loops we are taking, and the decision where we are required we are taking over here. And if you are going with n is equals to, so if whatever is there in this program we are writing over here. Okay, so this is called the one-to-one flowchart. In the next statement, what you are doing, this is the merging process statement. So in the previous diagram, what you have done this, just now I said that do that, guys. If you are just we are replacing the thing. Okay, replacing them with the simple numbers. Okay, that are existing in the program, it's okay. Okay, just we are replacing with that process into the simple numbers. Okay, so what you are doing in this second program is we are merging the process. So look at here, first, second, third thing we are merging this, and we are giving as a P1. Okay, this one is P1, then this is loop, and next we are merging these things over here, and we are giving the P3, and we are writing the Z is equals to N, and we are giving the simple name of this program. It is accepting, just as we are giving the name, simple name for that program. Okay, that line, that is P2. Okay, next we are merging this thing. Okay, Z is equals to, then we are giving P4. Okay, we are giving the name as this line as a, this node as a P5. So we are having single line, or we have the two lines, one lines. We are merging the lines and we are providing a single name to that lines. Okay, so 1 2 3, these three nodes we are merging and we are giving this three node as a P1. Okay, next we have the P2, that is the string. So this node we are giving the name as a P2. Next we have these two lines and we are merging these two lines and we are giving these two lines as a single name, that is P3. And this line is we are giving the P4 and this line is we are giving the name as a P5. These nodes we are giving the names as a single name, and that is P5, P1, P2, and this is the decision. We are not changing the decision. So this is called the simplicity flow chart. So in this chart, what you are doing is just program this program language. We are merging into the single line. So these three lines is a P1. Okay, this is the P2. This one is P3. This one is P5. See, this we are doing in the program. This is called the merging process statement. Okay. Next, what you are doing means, so in the second diagram, what you have done means we have the merges the steps. Okay, the process. Okay, process steps and replace them into the single process block. Okay, when we have now to control flow graph. Okay, that is, now we are representing the control flow graph, but this representation is still too busy. Okay, it is busy. We are simplifying the notation for the achievement. So we will look over next diagram. So in this, what we are doing, we are with that control flow diagram, we are merging as a simple wave. Okay, we are representing it is in the simple wave. Okay, so look at here. So same here, we are doing the same thing over here. So we are giving the names for junctions also, decisions also. Okay, removing the extra labels. Okay, we are removing these extra labels and we are giving the names to the nodes. Okay, representing the elements in the as a number. So what you are doing in the second thing is just what in the first steps what you have done. We have given the numbers to them, and this now we have reviewing the decision extra everything we have written. Just we are giving the names to this line. That is, this one is 1. Okay, decision 2. So look at this, decision 2. Then 3. Okay, then 4, 5, 6, 7. So we are giving the nodes names in the simple way. Okay, we are doing in the simple. Okay, we are representing into the still they are busy stage. Okay, now we are doing into the simple stage. Okay, we are giving into the simplification of that program by giving the simple numbers. Okay, so now with the diagram we are representing a linked list notation of a control flow diagram. So the nodes. So this is on first node, second node, third node, fifth node. So this names we have given. Okay, nodes. Okay, for nodes we have given the names. In that names we are representing these lines. Okay, this is the code is there in that line, in that node. Okay, so in the first statement, in the first node, what we have input is x, y, z, z is equal to z. So these three lines we are there in the first line. So we are writing over here. First is node 1. How many nodes are there? We are writing over here, and the process, labels, decision, whatever there we are writing over here. And the next node what will be there? We are writing in the next node. Okay. So in the first node we have this thing. Okay, this line process. So we are writing over here. This processes will be there in the first line. So in the second we have this one, this thing, condition. Okay, this decision. So we are writing over here. Okay, in that we have the true or false. So we are writing over 4 and 5. Okay, they may be go into the true statement or they may be go to the false statement. Okay, here or there. So you are writing over here. Okay, next we have the fourth line is in this. Look at this one. Okay, so we are writing over here. Okay, next we have the fifth, next sixth, then the fifth line is the loop, then we have in the loop we have the sixth or seventh, and next we have the seventh line. Okay, the end of the program. So we are representing in the flow control graph. This is the diagram of flow control graph, and this is the list we have to represent of flow linear list notation of flow control flow graph. Okay, are you clear with this topic? Nothing is that in this control flow graph, what you are doing is in the program you are giving the notes. Okay, you are giving the links and notes. Now in that links you are representing the simple way, in the short and simple way to understand that. So now that thing we are drawing in, we are making as a table. Okay, in each note what lines, what is the process is occurring, and the next note of the process, and the where the decision is taken, we are doing that. Find the first diagram what we have taken, just we have done, we go with that process, only process lines. Okay, only lines. Okay, then in the second statement we have removed the extra things. Okay, in the second thing we have merged that. Okay, first we have drawn the diagram, control flow diagram, simple control flow diagram, that is called the one-to-one flow chart. This diagram is called the one-to-one flow chart. Next we will go to the, we have merged that. Okay, we have simplified that thing, then we have given the one name, and then the second next what we have done that we have removed all the extra things. Okay, like Sam, Joey, loops, this we have removed, and we have the condition. That condition also we have given the one name to that conditions also. So each and every note we are providing the one names. Okay, this is your diagram, control flow graph. So this is the flow graph. In this flow graph, what you are doing is, what in the first note what the process is taking, you are writing on the over here. Okay, in the next node, where from the first node where it will go on the next node, so it will be showing over the next node, and the next third node, so it will be showing the next node. If you are this node, why you are showing about the next node, it means if you are having the loops, right, from it is not necessary from second to third it will be go, it is not necessary, it will be go from in the conditions it will be go second to fourth. So we have to know that what the next node it will be transferred, it will be go. So you have to know that for that purpose we are writing the next node over here. Are you clear with this, sir? Hello, there's something guys. Hello, are you clear with this? Okay. Okay, give me the attendance, guys. One second, guys.